In this video, we will talk about the throw keyword and the throws keyword. The throws keyword is used to specify what kind of exceptions a method might throw. A throw keyword is used to manually throw an exception. So let's see how throws works. We'll get rid of method 4 for now. And let's say in method 1, instead of these two instructions, we have this instruction. We have not looked at writing or reading files in Java in this course yet. But for this example, let's look at a statement that prints some output to an external file. We use a print writer resource and a file writer resource, and this statement then allows us to write whatever output we want to our file, whose name is myoutputfile.txt. The statement that creates a file writer can fail for a number of reasons. For example, the constructor of the file writer can throw an IO exception if the program cannot create or write to the file that's indicated here. It might be because of permission issues or some other issues that prevent the file writer from writing to or creating the file in the first place. If the file writer cannot create or write to this file, then this statement will give us an IO exception. And IO exceptions are checked exceptions. Remember that checked exceptions are checked at compile time. So if we do not handle the IO exception, then this will not even compile because the exception would be checked at compile time. Since IO exception is a checked exception, it needs to follow a rule. In one of the previous videos, we discussed that rule. That rule was catch or specify. Every checked exception has to be caught or specified, or else the program will not compile. Now, because the statement that we are working with will throw an IO exception, which is a checked exception, we have to catch it or specify it. We already know what catching means, so let's look at that first. Let's write a catch block to catch the IO exception that this statement might throw. So we will put this statement in a try block, and until we write a catch block, this will keep on giving us this error, which would say that we have to handle the exception, which will be a java.io.io exception. So let's write the catch block, and we'll specify that we will be catching an IO exception. As soon as we specify that we are going to catch an IO exception, our error goes away. Remember that we have to do this, and if we don't, our program will not compile because IO exceptions are checked at compile time. And let's say we just print something out here. So in case we get an IO exception, that exception will be thrown from the try block and it will be caught by our catch block. So this is an example that shows how to take care of a checked exception. And what we're doing is that we're catching the checked exception so that our program does compile. We can also specify the type of exception that our method would throw, and that will also allow us to get the program to compile. How do we specify an exception? So instead of writing a try catch block, we will specify that method 1 can throw the IO exception. So let's get rid of the catch and try block. This returns us to our previous state when we had the error. So we still have an unhandled exception. What we can do is that we can use the throws keyword. We can say that method 1 throws IO exception. And when we do that, our error from this part is gone. What this actually does is that it gets rid of the requirement to handle the IO exception here. So if we specify that our method throws IO exception, in that case, we do not have to handle the exception here. But the exception still needs to be handled. Where will the exception be handled? If any other method calls method 1, that method now will need to handle the exception that might be generated from this statement. So whoever calls method 1, if an exception occurs in method 1, then the exception object that gets created will then get passed to the calling method, and that calling method will need to handle the exception, which is why we see that now we have an error here, and it says that we have an unhandled IO exception in this part of the code. Why? Because now we know that method 1 throws IO exception. However, when we're using method 1, we did not handle it. So we have to handle it whenever we call method 1. So we should be handling it here. So let's put method 1 in a try block. The catch block will catch the IO exception, and we can print something out. So method 2 called method 1. Method 2 was the calling method for method 1. Method 1 throws an IO exception. Because method 2 called method 1, method 2 must have the capability to catch the exception that method 1 may generate. What this does is that it frees up method 1. Method 1 specifies what kind of exception it'll throw, but does not handle the exception itself. Any other method that calls method 1 will need to handle the exception. And that's what throws keyword does for us. Why do we need it? Why do we need a method to only specify what kind of exception it will throw, but never handle it? Imagine that you are writing a class that other programmers will use. Since we do not know their needs and what they would want to do with an exception, when we write our class, and if we have a part of our class code that can throw exceptions, we just specify what kind of exceptions it might throw. When someone else is using our class in their own program, they will now have the flexibility to handle the exception in any way they want. So this makes the whole process a lot more flexible. When a method uses the throws keyword followed by some exceptions, we say that that method has specified the exceptions that it'll throw. And if we want to add more exceptions here, we can just use a comma and add more exceptions. If method 1 also has some other code that might throw null pointer exception, that we can specify too. And we can add more exceptions here. So method 1 can specify as many exceptions as it needs based on its code. But remember that IO exception is a checked exception. Null pointer exception is an unchecked exception because null pointer exception is a runtime exception. The rule that we discussed about catch or specify only applies to checked exceptions. Unchecked exceptions do not have to follow this rule. Because we were handling an IO exception, we had to either catch it or specify it. And we looked at both examples. At first, we wrote the catch block and put our statement in a try block. The second example we saw is our method specifying that it throws an IO exception. So catch or specify will apply to IO exception, but it will not apply to null pointer exception. This means that we have to do this, but we do not have to specify this, because this is a runtime exception, which is an unchecked exception. So throws keyword is used to specify what kind of exceptions a method may throw. And this gives us the flexibility of not having to handle the exception in that method. Some other method that calls this method now has the responsibility of handling any IO exceptions if they occur from method 1. Great, so now we understand the throws keyword. Let's look at throw keyword. The throws keyword is used to specify the exceptions thrown by a method, as we just saw. The throw keyword is used to manually throw an exception. So let's try and look at an example that does that. Let's say in method 3, we are trying to divide one integer by another. In that case, let's give method 3 some parameters. Let's say whenever we want to use method 3, we have to input a numerator and a denominator. What we want to do is throw an exception manually if the denominator is 0, let's say. So we can do that using an if condition and say if denominator is 0, then we will manually throw an arithmetic exception. So we use the keyword throw, and note the difference between throw and throws. They do two very different things. So we use the throw keyword, and then we use new, and then we use the exception name. And in the exception name, we can specify some message. And since we're trying to divide the numerator by the denominator, our return type would be float, let's say. And if the denominator is not 0, then we just return the result of the numerator being divided by the denominator. So here we are manually throwing an exception. Let's try and call method 3 from the main method and see how this works. We already have our propagate object, so we'll use the propagate object to call method 3. And here we'll pass the numerator and denominator integers. Let's say our numerator is 5, and let's say our denominator is 0. Let's see what happens when we run the code. You see, we have the outputs for our first statement and also the second print statement. Both of them are in our output console, but then the exception is thrown, and that is because our denominator is 0. We manually threw that exception, and that exception caused our program to stop. The message message we wanted to have with our exception is denominator cannot be 0. And you can see that the arithmetic exception is accompanied by that exact message. So we threw an exception manually with a custom message. And because an exception is thrown, our program ends abruptly. If we want our program to continue, we must handle the exception that was thrown. What we'll do is put this statement in a try block, and in the catch block we will handle the arithmetic exception. And let's say we print out that the denominator was 0. If we run the program now, we'll see that we have normal flow. So you see we have all the outputs from start to end. We don't have an exception stopping our program abruptly because we handled it. Since we caught the exception, this is what was printed in the output console. Hopefully this shows you the difference between throws and throw. Throw is used to manually throw an exception when we need to. Throws is used to specify what kind of exception a method might throw. So this concludes our discussion on the basics of exception handling in Java. In the next chapter, we will talk about multi-threading. See you in the next video.